Let's continue discussing requirement 1 of CCIE LAB. 101.10 is about BFD configuration. Where should BFD be configured? In our entire topology, there's a carrier SV1. It has a direct connection with two devices in area 3. One is device R5, which is directly connected to 61R261, and the other is device R6, which is directly connected to R262. There are certain requirements for the public network links between these two devices. Since these are BGP links, and BGP links are vulnerable if the link goes down, we need to configure a detection mechanism to monitor these links. The detection requirement is that the very first and primary requirement is that we meticulously configure it between 5 and 61, right? Specifically between 5 and 61, we must carefully configure the enhanced fault detection function, and additionally, we also need to configure the enhanced fault detection between 6 and 62. That is to say, BFD is commonly called bidirectional link detection, and this BFD protocol is also configured between these two crucial points. Then, when BFD is indeed configured, it absolutely requires that the detection time interval must be precisely every 333 milliseconds. If there is absolutely no patrol response after 3 consecutive detections, it definitively means that the other party has not responded. That is, the other party has not successfully sent the BFD packet. So we then consider that the link is indeed faulty, right? Then once a fault or an issue occurs, the BGP neighbor relationship must be disconnected immediately and without delay. That is to say, we are effectively applying BFD within the context of BGP, right? Until the link is fully restored, the BGP link will be restored from the logical level. That is, the BGP neighbor relationship will be completely restored after the physical link is successfully restored. The following requirement means that if there is an illegal access attempt, this user is attempting to establish a BGP connection between 5 and 61, or alternatively between 6 and 62, to prevent any unauthorized access. The requirement generally states that we can effectively prevent unauthorized users from establishing neighbors. The method specifically mentioned here is to change the BGP neighbor relationship to a single hop. Then, the TCP connections between 25 and 61 and also between 65 and 62 must have MD5 authentication enabled. This particular configuration is very simple to implement. Just configure a passive. Let's carefully look at this operation. This requirement is indeed very simple. Let's first work on 25, specifically between 5 and 61. There's a clear requirement that states that MD5 must be enabled between 5 and 61. That means authentication is absolutely required between 5 and 61, while authentication is not explicitly required between 66 and 62. On the right link, BFD doesn't require authentication. This side uses authentication, and the left side uses authentication. Let's first look at 55. I'm going to access this interface memory 0, 0 interface memory 0, 0 interface 0, 1 interface 0, 1 interface memory 0. 1 interface and then BFD, which stands for bidirectional forwarding detection, is turned on. First, BFD is turned on globally across the entire system. The detection time is set to 33,333 milliseconds, which is a relatively precise and specific timing for detecting failures. The detection number, or the number of consecutive failures before a link is declared down, is set to 3 times, right? That is, BFD is enabled, and the minimum sending interval for bidirectional internal detection, meaning how frequently BFD packets are sent between devices, is 332 milliseconds, right? It is detected once every 330 milliseconds. Then, if no BFD packet is received from the other party for 3 consecutive times, it is definitively determined that the BFD drawing is good, indicating a stable connection. Then it goes to BGP, which is the Border Gateway Protocol, specifically BGP 10,000. This 10,000 is its AS number, or Autonomous System Number, which uniquely identifies this network. This particular AS number, 10,000, is the ASAS number of the operator above, likely an upstream service provider or a larger network entity. Then the DRATS family IPv4 VRF enters this. It itself has this VRF, which is a virtual routing and forwarding instance, allowing for multiple independent routing tables within a single router. In this case, let's look at the BGP configuration in more detail. In the BGP process, there's an address group with an instance, right? This address group with an instance contains the neighbor on the other end, the peer router with which this device will establish a BGP session. We mainly configure this, as I've already done before. I'll show you how to do it here. After entering this address group, knocking on the door points to the neighbor. I don't know the neighbor's number, right? I can see my own G0-1 introduction, SORI interface, IP interface, SORI interface. It doesn't use this software port. I can clearly see my own 0-1 introduction, which is 100, 5, 61, 1, right? Then my far end neighbor must be 61, 2. So I just point to this neighbor 100, 5, 61. 2, then set the TTL value to 1. That means my eBGP packet can only be forwarded one hop, right? If a remote device wants to establish a BGP neighbor relationship with me, it can't, right? An illegal neighbor can't be established. Okay, then let's still point to that neighbor, Nable 100. 5, 61. 2. Then subsequently, we will need to meticulously create this specific BFD drawing, and then, with careful consideration, we must bind it directly and securely to this particular BFD drawing. Following that, we will proceed to implement and add an MD5 authentication, which is a crucial security measure, right? 100, 5, 61, 2. It's my custom. Then, according to the exam requirements, give this JC reference number 1 reference NFR4. This configuration is complete. The configuration on 61 is the same. I will demonstrate again that the interface on 61 is GD0. 0 interface 0. Enable BFD on interface 0 and run a comprehensive check every 3 seconds. The interval between each individual check is 333 milliseconds. BGP 65006 does not recognize AS number 3. The AS number is 65006. There is no VRM instance present here, so we are testing it globally. We do not know if it has an instance or its specific configuration. We can utilize this command, running configure, followed by a space. This is specifically called session. Router BB is BGP. You can type the full BGP or OSPF command. I am using the global unicast JT group for IPv4 to meticulously check the neighbor on the other end. On my 61, I just type these commands directly. And the internal neighbor 100, 5, 61, 1. We just checked this, right? It's TTL. The TTL for BGP interaction packets is set to 1. Then enable BFD reporting on this internal neighbor, and for the internal neighbor 100, 5, 61, 1. Then it says my C3 reference number 1, reference NF24, all set. Now the configuration for 51, 61, and 62 is exactly the same as the configuration for the two devices on the left. Their configuration is identical to theirs. The only difference is that on this side, authentication is not required. The BFD between these two devices on this side does not need authentication, so you do not need to configure the password. On the left side, you do need to configure it. It is just that simple. If you want to know more about C3E live exam materials, please send me a private message, or you can leave a comment below the video. Leave a comment below. 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 Leave a comment below.